Hi, my name's Christine and welcome to my Basics of SPSS workshop. This workshop is in two parts. This is part one and it's called Getting Started, and we're going to look at how we enter data and define variables in SPSS. Part two is Descriptive Statistics and Charts and Graphs. This workshop is intended to be hands-on. That means you do the SPSS with me and follow along with all the examples. I do encourage you to try the tasks and to pause the video while you try them, just so you can think about it on your own before you see the answer. I will be using a couple of files, one file in this part and one file in part two, that are available on Blackboard Learn in the Ask section. And when I come to use those files, I will show you how to get them. Okay, well, let's get started. Now, the objectives of part one of this workshop is first, as briefly mentioned, the purpose and use of SPSS, because I do think it is a misunderstood software. Second, I'll show you how to open up SPSS on a Brunel computer. Now, in SPSS, it's different from Excel. In Excel, we can enter any data however we want, arrange it any way we want on a worksheet. SPSS is different. It's made for statistical analysis, so you need to enter your data a certain way. You have to enter variables in columns, and you need to define them. So in order to do those things, you first need to know what your variables are and be able to identify them in your data set. So we're going to look at some examples of that. Now, once you know what your variables are, you can define them in SPSS. And once you define them, you can go ahead and start entering your data. Now, once you've entered all your data, you're going to want to save your files, and I'm going to show you how to save them so that you can find them later, and then also be able to open them at another time. And for those of you who are going to have data in an Excel file, for example, you may have done an electronic survey and downloaded all your responses in Excel. I'm going to show you how to import that data into SPSS. And finally, I'm going to show you how to handle missing data. I'll give you a couple options of what you can do in SPSS. Okay, the purpose and use of SPSS. It is a statistical software package. However, it is just a tool. And what I mean by that is it only does what you tell it to do. It's really important to know that. It does not think for you. It's not a black box. I can't put in my data and tick a box that says questionnaire and click an analyze button. It just doesn't happen. The analysis is completely dependent upon you and what you're trying to accomplish with your research, what your hypothesis questions are. So that means you really need to know the correct stats before you get started using SPSS. If you don't know what you're going to do, what analysis you should be doing, then you're not ready for SPSS. You can go ahead and enter your data, but you're just not ready for analysis. The software will not make sense. You won't know what you're doing, but your problem will not be SPSS. Your problem will be that you don't know the statistics. Once you know the stats, then you're ready to do your analysis in SPSS, and everything will make a lot more sense. All the output will make more sense. Okay, so let's go get started. I'm going to show you how to open it up on the network. Now, on the left-hand bottom corner of your computer, you should have a Windows Start icon. My computer is Windows 7, so that's what my icon looks like. And go ahead and click in SPSS 18. Now, this is how you find it on the Brunel network, not on your own home PC. It'll be slightly different. Once you type in SPSS 18, go ahead and click on it from the list of programs. Now, there is a version 15 still on the network. Please don't use that version. It is being discontinued, so it's best to use version 18, and that's the version I'll be using throughout the workshop. Now, once you click on SPSS 18, it will take a few minutes, it will take a few minutes to open, so do be patient. You can go ahead and pause this video while you wait for SPSS to open. Now, once SPSS opens, you're going to see this dialog box, and you have a few options. Over here on the left-hand side, you have open an existing data source. I never use this option because I do get some problems on the network, so I always prefer to type in data and then click OK. Even if I have an existing file, I always use this option. Now, just a word of warning. If you're using a Brunel computer, you have to open SPSS first, then you can open or type in your data. Now, usually we click on a file and it opens. If you try that with an SPSS data file, it will either say that the license is not available or it will crash. And that's if it's on the network. If it's on your home computer, there usually is not a problem. So please do open SPSS first and then open your data file. Now once you click OK, you'll see an SPSS data file open. Now on the bottom left hand corner, you've got two tabs. You have a data view tab and a variable view tab. This is different from Excel. In Excel, you've got worksheets, and you can add worksheets or take them away. In SPSS, you only have two. You have a data view and you have a variable view, and you cannot add more and you cannot take them away. The variable view, as the name suggests, is for your variables. So here you will define all the variables in your data set. And in this first column called name, you're going to list all the names of the variables that you have. And then in these columns here to the right, this is where you tell SPSS about your data. You can give it more information with a label. You can code it with a value label. You can code missing data. You identify the level of measurement. And we're going to come back to all of these just a bit later. Now once you have your variables defined, you're going to want to go ahead and click on the Data tab. In the Data view, this is where you enter your data. It's your data only. Do not enter variable names in the first row like you would in an Excel spreadsheet. It's only data. Once you have variables named in the variable view, they will appear as your column headings here across the top, where it says var, 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 var in gray. That will be replaced by your variable name once you've defined them. And then you can come to the data view and enter all of your data. Okay, let's make sure SPSS is working properly. There's a couple errors that can happen. The first one, you should have a full menu across the top. So I've got File, Edit, View, Data, Transform, Analyze, etc. Now if you don't have that, if you only have this, File and Edit, then something is wrong, and I'm going to show you how to fix it. You're going to need to close SPSS. Okay, once you've closed SPSS, you go ahead and click on the Start icon and find My Computer. And then I want you to find your H drive on the Brunel network and go ahead and open it up. Now in your H drive, you will see a folder called SPSS 1802. We're going to delete this folder. Don't open it. It's just a temporary file, so it's okay that we delete it. And now that we've deleted it, I'm going to go ahead and open up SPSS again. Okay, now that we've got our first error sorted out, let's have a look at the second and last error that commonly occurs. When students go to enter data, they commonly get question marks instead of the values that they're entering. So let's make sure that's not going to happen to you. So let's go to the Data View tab, which I am here, and we're going to enter the numbers 1 to 5. We're not going to worry about defining variable names at this point. SPSS will just create one for us. So I'm going to enter 1, 2, 3, 4, and 5. Now I have my numbers here. This is what I want to see. If you're getting question marks instead of these numbers, then that's a bit of a problem, and I'm going to show you how to fix it. All you need to do is go to File, New, and select Data. And a new data file will open up, and I can go ahead and close any other data file that's open. No, I don't want to save changes. And I'm going to work with my new data file that opened up. Alright, now that our SPSS file is working properly, let's look at how we start entering data and defining variables. The first thing we're going to look at is our variables. What is a variable, and then how do we define it in SPSS? A variable is a measurement. That could be a measurement of nearly anything. So for example, it could be a characteristic if you've got a group of participants or subjects. For example, their age, their gender, their height, their weight, what university they go to, what they studied, what their career is. All those kind of things are characteristics about people. It could be time points. So for example, I could have one group of participants and I could be testing them over time. I could have a pre-test and a post-test, or I could have an initial time, a time 1, time 2, etc. So each of those time points I'm taking a measurement. So say for example, I've got a diet pill and I take people's weight at time 0, which is the initial time. Then I take their weight again at time 1 and then their weight again at time 2. That would be 3 different weight measurements, and that would be 3 different variables. The next one is an experimental condition. So for example, if I've got a group of participants and I split them up into say 2 or more experimental groups, that means I need a variable which denotes which experimental group or condition they were allocated to. It could be an opinion or belief, say from a questionnaire. So I could ask for a participant's level of agreement with the statement, or a level of satisfaction, etc. There's lots of other things that could be measurements for variables. These are just a few of the most common that I see amongst students. So I'm going to look at some examples, and then we're going to take a bit of practice and see how you get on. These are variables from a questionnaire, and I just got them entered in Excel at the moment because I'm going to need to code them before I put them into SPSS. So my first column is my participant ID. I really suggest that you have a subject ID or some kind of ID column as the first column in your data set, unless it doesn't make sense to do so. But for most people, particularly if you have a questionnaire, have an ID column. The reason is you can always go back and check certain IDs and participants. If you don't have the ID column there, then you can't do that, and you might have to enter all your data again. So good idea, have an ID column. My second column is gender. Now gender is my variable. Are you male or female? That's my measurement. So variables go in columns. I put gender as my column heading, and all my data goes in that column. The next one was how long does it take you to, on average, to commute into uni, and that's travel time. Travel time is my variable. It goes in a column, and then all the measurements go underneath it in that same column. What is your main mode of transport? So I've called that variable mode, and all the measurements are the participants' mode of transport. So TFL is public transport, car, cycle, walk. How do they get to uni? And the last variable was on a Likert scale, indicate your level of agreement with the statement. Most days, my commute causes me to feel stressed when I arrive at university. So stress is my measurement, and all the responses there go underneath it in the same column. So variables go in columns. That's really important in SPSS. Like I said, it's different from Excel. Excel doesn't care where we put data. We can enter it anywhere on any worksheet. SPSS is really particular. Variables have to go in columns. You can't enter it in the same way. Okay, so let's look at our first example. We've got a random sample of 200 residents of Uxbridge, and we've asked them their view on stem cell research using a 3-point Likert scale. So do they agree, have no opinion, or disagree? And then we asked them a second question, if they believed global warming was an important issue. We used a 5-point Likert scale, so from strongly disagree all the way to strongly agree. Now take 20 seconds, 30 seconds, however long it takes. There are 3 variables here that I want you to identify, and then come back. Okay, so I hope you got all 3. The first one is my residents. I always need to have an ID column for my participants, so that always goes as my first variable. My second variable is on stem cell research, and for that variable, my responses are going to be from the Likert scale. And my third variable is a measurement about their opinion on global warming. So if I was going to enter this data into SPSS, my variables go in columns, and it would look something like this. So I've got my resident column, my stem cell column, and my global warming column. And this may sound a bit obvious, but make sure to have your responses line up with the right participant. So row 1 is always resident 1 or participant 1, etc. Okay, here's another example of data that you might need to enter. So I've got experimental conditions this time, and they're independent conditions, and that means participants are in one condition or the other condition, but not in both. Okay, these are independent conditions. So I need a variable called condition, and then in that column, I'm going to identify which condition each participant is in. So participant 1 is in condition 1, participant 3 is in condition 2. And then I've also taken a score on a test for each participant, and that's out of 20. And that only goes in one column because every participant took the test. Okay, so here's task 2. This scenario is we have 30 participants and we're trying to understand the effect that caffeine has on their ability to sleep. So these participants, they were randomly assigned to one of 2 conditions. So there was a control group, which was not given any caffeine. They were given like a placebo. They thought they were given the caffeine. And there was another group that was given a dose of caffeine for every 3 hours between 9 and 6 p.m. And then every participant had to measure their ability to sleep at night. And then we took the average over those 2-week period. Okay, I want you to take about 20 to 30 seconds. Just have a think. What are my 3 variables here? Okay, did you figure them out? The first one is obviously going to be our participants, right? We have to have a participant column. My second variable is actually the condition. And for that condition, a participant is either in the control group or the caffeine group. And my final variable is the average number of hours slept. So if I'm going to enter this data into SPSS, my variables go in columns. It's going to look something like this. So participant ID, the first column, my condition, where I have control or caffeine, and then the average number of hours slept. Okay, the last example is with a repeated measures design. So in the second column here, I have a variable called status. So we have a group of patients and they're entering hospital. Now their status is they're either non-terminal, meaning they are going to get better and they will leave, or they're terminal, meaning they're coming to hospital and they're not going to get better and they're going to die in hospital. My next 3 columns are anxiety scores. So we're trying to measure how anxious people are while they're in hospital. So baseline means when they arrive, and then after 2 weeks, and then after 4 weeks. So we're giving them an anxiety score at each time point and every participant is taking it. Now, why don't I enter time like I entered status? So, for example, have baseline 2 weeks, 4 weeks in there, and then have an anxiety score. Well, I have 3 time points for every participant. If I do it this way, I cut out a lot of information. So for participant 1, I only have a baseline score. What about 2 weeks and 4 weeks? So because every participant took the anxiety test at all 3 time points, I have to enter my data the way I did before, like this. Okay, so let's look at our last example. This is about fitness regime. So we've got 50 participants, and they're all different sorts of fitness levels. And we're trying to see if a personal trainer really makes a difference, or maybe it's just psychological, having someone to help you along, a bit of motivation. So the 50 participants were randomly assigned to one of 2 training groups. They were either self-trained or a professional trainer. Now, those who self-trained had to make up a training regime, and for a professional trainer, someone else, a professional trainer, gave them a training regime. Each participant had to run or walk a mile as best they could before the study started. And then after the 30 days of their training, self-trained or professional, they had to do the mile again to the best of their ability. And it was recorded. So I want you to take maybe 30 seconds, maybe a minute. Think about, what are my variables here in this problem? Okay, so my first variable is always going to be my participants. My second variable is I have these training groups, and because they're independent, meaning it's a self-train or a professional trainer, but not both, I just have one variable called training groups. Now my next one is the mile time, and this is the start of the study. And my final variable is going to be the mile time at the end of the study. So this is a pre-test, post-test scenario where I have a repeated measure. Now, I want you to just take a minute and think about how will you enter the data in columns. If you need to, just go ahead and pause and just take a bit of time. Maybe think about it or just sketch it out briefly. How will you enter the data? And then I want you to record some hypothetical data for 2 participants. Okay, so my variables go in columns. So I've got participant, my training group, I've got my first mile time and my second mile time for my pre and my post, and just putting in some hypothetical data, self-trained, professional trained, maybe a first mile time, second mile time, just so you get the idea of how the data would be entered. The most important thing is knowing that variables have to go in columns and knowing that when you've got repeated measure design, that each of those measures needs to be a separate variable. But if you have a condition that's independent, like training group, you have one variable for training and you identify which group the participant was in. Okay, now that we can identify our variables, the next thing that we need to know before we start entering the data is the level of measurement. This is really important. The level of measurement should determine what kind of statistics that you use to answer your research question. So for our variables, we have 2 types. I've called them categorical and scale. Now, categorical is commonly known as qualitative, and scale is commonly known as quantitative. And the reason I've used the word scale is because this is the terminology used in SPSS, and I just want to be consistent with the software. I'm going to start with categorical. Now, categorical data, this is data that's in groups. And there's 2 types. The first type is ordinal. So a common ordinal variable is a Likert scale. Now, a lot of people think that Likert scale is scale because the word scale is in the name. It's not. A Likert scale is words: strongly agree, agree, undecided, disagree, strongly disagree. Those are words. We do code them, but because it is categories, it is words, it is ordinal. It's not scale. It's really important. So with ordinal data, it's ranked. It means it has a meaningful order to it. So my Likert scale has a meaningful rank or order, maybe a level of agreement, a level of satisfaction. The second category is called nominal. Now, these are categories that do not have a meaningful rank or order to them. So, for example, marital status: single, married, divorced, widowed, separated. Those are categories, but I can't rank them in any particular meaningful way. The same thing with, say, hair color, eye color, the color of your car, what kind of phone that you have. Those are all categories, but I can't rank them. So those would be nominal. Okay, so ordinal is ranked categories, nominal is unranked. Now, scale is anything that's not grouped. So, for example, if I ask people how old they are and they write in their age, I'm 23, I'm 18, I'm 21, that is not grouped, it's scale. However, if on my questionnaire I say, how old are you, and I have groups, 18 to 24, 25 to 30, 31 to 35, etc., I've now grouped the data. I no longer have scale data. It's ordinal because those groups have a meaningful order. They are increasing with age. Okay, same thing with income. If I ask someone how much they make annually, that would be scale, but if I have income groups, it's now ordinal. Okay, now like I said before, these are really important because it should determine what kind of statistics that you can do. You cannot do the same statistics on scale data and, say, nominal data. It's 2 different things. If you do, you're going to get some results, but they won't be correct, and they'll be pretty much useless. So what's the point of having results if they're meaningless? Okay, so it's really important. And we can define this in SPSS. Now, SPSS will let you do certain things with the wrong type of data, and that's why it's really important that you know what you're doing. So the classification is partly there for SPSS, but it's partly there for you so that you remember what type of data that you have. But it will affect what type of charts and graphs you can make. So for example, if I say a variable is scale, SPSS will not let me make a bar chart with it. It has to be categorical. So it is important in that respect for making charts and graphs. You do need to have it classified properly. All right, now that we know what our variables are and we know our level of measurement, we can go ahead and get started with entering data. But the last thing we need to do is code all of our categorical variables first, and then we can start entering them in SPSS. Remember, SPSS is a quantitative software. It's not really for qualitative data, so it is important that we do code all of our categories first. Now, remember this example from before. I had some questions from a questionnaire. All of my categorical variables need to be coded. My scale ones don't need to be coded. So my participant ID is already in number form. I don't really need to code it. I'm just going to leave it as it is. I will never use my participant ID in analysis. It's only there for my reference. So I'm going to leave it as it is, and I'll probably put my level of measurement as scale. The second variable is gender. So what's the level of measurement for gender? If you said nominal, then you're correct because gender is categorical and male and female cannot be put in any kind of meaningful rank or order. So it would be nominal. For this example, I've got male as 0 and female as 1. So I'd replace all of my responses with my code, and then I could enter the codes into SPSS. My next variable is travel time. So what's the level of measurement for travel time? If you said scale, then you'd be correct because it's not grouped in any way. I have the actual time in minutes for somebody's commuting time. It's not in intervals or groups. So it's scale, and scale data doesn't need to be coded, so I can leave it as it is. My next variable is mode of transport. This is how somebody commutes into university. So what's the level of measurement for mode? If you said nominal, then you'd be right because I've got categories again, and these categories don't have a meaningful rank or order. The mode of transport, I can't rank it in any way, but it does need to be coded because it's categories, and I've chosen to number them from 1 to 4 with public transport, car, cycle, and walk. Now, because it's nominal, the order in which I number them does not matter. I could jumble those up in any way and put any numbers next to them I wanted. And I'm going to replace my responses with a numerical code, and then I'm going to enter that code into SPSS. My last variable was this stress measurement, so how stressed someone feels by the time they come into university. So what's the level of measurement? Well, I have a Likert scale, don't I? And remember, Likert scales are ordinal because they are categories, but those categories have a meaningful order to them. So I'm going to code them from 1 to 5, strongly disagree to strongly agree. Now I could reverse that and have 1 be strongly agree down to 5 being strongly disagree. That's okay, but I cannot jumble up those responses. So I can't put disagree, agree, I don't know, strongly disagree, strongly agree. I can't jumble it because those responses have a meaningful rank or order to them. They need to be in that order, but I can reverse the coding if I want to. So now that the data has been coded, we're ready to enter it into SPSS. So now we're going to enter our data, and to do that we need to go to the variable view. So make sure you click here on the variable view tab, and we're going to enter 3 of the variables that we were just looking at. The first one, of course, is our participant ID. Now, variable names cannot contain any spaces or special characters. The only exception is an underscore. So for your variable name, make sure you don't put participant space ID. The next variable I want to put in is gender. And the last variable I'm going to use is travel time. And again, I don't put any space between travel and time, it's just one word. Okay, the next column over is the type, which is here. Now all of our data is basically going to be numeric, so we're not going to change this column. We're just going to leave it as it is. And then width is referring to the width of the column in the data view. I generally just leave it as its default. The next column is decimals. Now this is the number of decimal places that we're going to see in the data view. So just to show you an example, if I pop over to the data view for participant ID, I'm going to enter 1, 2, 3, 4, and 5 because I've got 5 participants. Now you notice it says 0.00, so it's showing me 2 decimal places. I don't like that because there shouldn't be any decimals on my ID, so I'm going to go to variable view, and in the decimals I'm going to put it to 0. If I go back to data view, you'll see now that I just have 1 to 5 without any decimal places, and that's what I want. I'm going to do the same thing for gender because I'm going to code gender as 0 and 1, but I don't want decimal places. And the same for travel time. All my travel time is in whole minutes, no seconds, so I don't want any decimal places. Now my next column is the label. The label is really important. It's where you give more detail about your variables. Your variable name is short, concise, to the point. The label expands upon that. The label is what will appear in all output, charts, graphs, tables. So take your time, put in a good label. I'm going to put participant gender. Now here's travel time. This is where the label's going to be beneficial because for gender it's really the same as the variable name. So time it takes to commute to uni. And then in brackets I'm going to put min because our level of measurement, or not our level of measurement, but our units is minutes. And it's a really good idea to put your units in the labels column. Now the next column we're going to look at is the values column. Now this is for value labels. They're like little label tags that you put onto your categorical codes. So the only categorical variable we have in our data set is gender, and we're going to code it with 0 and 1, where 0 is male and 1 is female. And I can tell SPSS what the 0s and 1s mean, or what they represent. And I'm going to do that here. So if I click into the values box for gender and click on this blue button, I get my value label dialog box. Now the value is my numerical code. So for male it's 0, and my label is male. And then make sure you click add. 1 is my next value and the label is female. And again I click on add. If you don't click add, then it won't be remembered or saved. Now I've got both of my codes in, both of my labels. I'm going to click OK. And that will appear here. Now when I enter 0 and 1 into my data view, I can choose to see male, female, or the categorical or numerical codes. The next column is missing. This is where we code missing data. So you can choose a number that's not in the data set. I typically choose numbers like 99 or 999 because they're not possible. Sometimes if a 99 is possible, I'll choose a -1. And make sure that you replace all of your missing values with the code first. And we're going to come back to this and do an example at the end. So I'm going to skip this for now. The last column that we really want to be concerned with is this measure column here. This is the level of measurement for our variables. Now we already said before, participant ID is scale, so I'm going to leave it as it is. And you can see here SPSS is trying to help you remember what these categories or these measures are. So next to the scale it gives you a ruler because these are ungrouped categories, they're scale measures. Ordinal, it gives you 3 steps and they're going in an ascending order to show you that there's order to your groups. And for nominal you have these bubbles here. And it's showing you've got groups, but there isn't any meaningful order. So if you don't remember, SPSS does try to help you along a bit. Now gender, what do you think gender is? Well, we did gender earlier, and we decided it was nominal because we have categories, but those categories don't have a meaningful rank or order. So I'm going to click on nominal, and my travel time is scale because it's not grouped or categorized in any way. Okay, so we've covered defining our variables and entering our data. We need to do a bit of housekeeping, so saving and opening data and output files. So saving a file, this is very similar to any other program, file, and save as for the first time. Every time after that you can just choose the save option. So go ahead, let's save the file that we just worked on. So file and save as. And then you'll get this dialog box here. So the first thing that you want to do is locate a folder to save it in. It will pop up with the default SPSS folder, which seems like I'll save my work there, it's SPSS, but really it's just a temporary folder and things can get deleted from there. So please do find your own folder and save it somewhere where you can find it later. So maybe create a separate folder for all of your SPSS data files. And down here, give it a good file name. Maybe date it depending on how many versions of your data you're going to have. And then as the save as type, it should say PASW statistics. It's because SPSS is taken over by IBM and it's no longer called SPSS, it's actually called PASW. And it has the extension .sav. And that should automatically appear up here with your file name. So once you found your folder, once you've given it a file name, go ahead and click on Save. Now once you save it, if there wasn't one open already, an output file should open up. SPSS likes to keep a log of everything that you do. And it also shows output for all the analysis that you run in SPSS. And it does that here in this main window where my mouse is hovering. So any charts, tables, graphs, statistical tests that you do will all be outputted in this space here. SPSS, like I mentioned, will also keep a log of all activity that you do while the data files are open. So here it says save out file because I saved my data file and this was the name of the file. So it just keeps a log. And if you look over here on the left hand side, it says log and it has a book that's open and that's the little icon there for the log. Now everything that you do will be shown in this big window, but also in a more condensed outline form here on the left hand side so that you can easily scroll through and click on the output that you want to look at without having to scroll through the main file. Now the last thing is that output files are saved with a different extension. The extension is .spv. If you remember, our data file from just before was .sav. They are two separate files. If you save your data file, it will not save your output file. And vice versa, if you save your output, it will not save your data file. I've had students who said, well, I saved my data file, and they thought the output file would save with it as if they were one, and it didn't, and they lost everything. So please do save them as two separate files. You can do it in the same way. It just shows you file, save as, give it a good name, and the extension will be .spv. Now one thing to note is SPSS always wants to have an output file open. So I'd suggest just leaving it open. If you close it, SPSS is just going to open another one, and you're going to be on a never-ending battle of closing and opening output files. So you can always delete the content from an output file. That's really easy to do. Just click on it and hit the delete button, but just leave it open. If you want to open a new file, you can open a new data file or a new output file. And you can do this from the data view or, the data file view or from the output file view. If you go up under the file menu and click on new, and then choose data for a new data file or choose output for a new output file. And you can have as many data file or output files open at one time as you want. I wouldn't suggest having multiple output files open because it's difficult to control where the output is put by SPSS, so I would just have the output file that you want the output to go to open when you do your analysis. Now, as I mentioned at the very beginning, you can open an existing SPSS file. You really need to open SPSS first. Once SPSS is open, you can open it this way with File, Open, and then you can choose Data to open an existing data file. You can even open an existing output file and continue adding output to it. As I just mentioned, do open SPSS first, because if you try opening it without opening SPSS, it's going to crash or the license will not be available. Alright, the next thing is importing data from Excel. And then the last thing we're going to do is missing data. So let's look at how we do that. As an example, I've put a Excel file on Blackboard that you can download, and you can go through this exercise with me. And I'm going to show you where on Blackboard you can find it. It's in the academic skills section of Blackboard, which should be under My Organizations. If you go to the Brunel Intranets page, down here on the side you're going to see an option for Blackboard Learn. Log in. And then if you scroll down here to near the middle or the bottom, you have something called My Organizations and Academic Skills. So if you click on Academic Skills, this is our main home page for Ask. And if you look here on the left-hand side, it says Workshop Presentations. And then if you click on Statistics and SPSS Workshops, and there should be one that says Basics of SPSS Part 1 and Part 2. And one of the attached files is called commutingsurvey.xlsx. And that's the file that I want you to save. Please do save it, don't open it. So I'm just going to save it to my desktop. And I'm not going to open it. I'm going to leave it closed, because you cannot import a file that's open. Okay, just a note on importing data from Excel. It can be an older version, an XLS file, or an XLSX file. Either one will be fine. I do suggest that you import variable names if you have them. To do so, they must be in the first row of the worksheet. Once you've imported your data, the variables will be seen in the variable view, and you can view all of your data in the data view. Now, just to look at the Excel file that you've saved, the file name obviously is Commuting Survey, which you saw already, and then I've got my variable names across the top row. I've got my participant ID, gender, travel time, my mode coded, and my stress coded. And I also just want to take a note of the worksheet that my data is in, because I'm going to have the option when I import my data to choose which worksheet to take data from. And this is the one that I want. Okay, so I'm going to close my Excel file, make sure it's not open. Please do make sure yours is not open either. Close Excel before we do the import. So go back to SPSS, and from the File menu, choose Open, and then choose Data, because we're going to open a data file. Now, the first thing you want to do is from this Files of Type option is you want to choose Excel. If you don't choose Excel, you will not be able to see your file. So choose Excel from the option here. The second one is find the folder where you saved the file. So this is the folder where my file was saved. And then make sure you click on the file that you want to open. Okay, but the most important bit here is that you identify Excel as the Files of Type. Once you click on Open, it will just take maybe 20 seconds for this next dialog box to open up. It says opening up Excel data source. I do want to tick the box that says read variable names from the first row of data, because I do have variable names in my first row. From the worksheet drop-down menu here, I want to choose SPSS import, because that's the name of my worksheet. And if it wasn't the right one, I could choose the correct one from the drop-down. And once I've done that, I can go ahead and click OK. Once you click OK, you'll see that all the data gets imported into SPSS. You can see I'm in the data view right now. We can see all our variable names across the column headings. These were from row 1 in our Excel file, and they have been imported as variables, so they're not as the data. They're not anywhere in the data view in this sheet here. It's just numbers. If we flip over to the variable view, we can see all of our variable names here, and we can see travel time min has been given a label. None of the other ones have. The reason this occurred is because in Excel, travel time with min in brackets contains 3 illegal characters. It has a space and 2 brackets, which are not allowed as variable names. So SPSS removed the space and special characters to create a new variable name called travel time min, and it's created a new label using my existing variable name. That's something to keep in mind when you import data from Excel. If you've got huge long questions as your column headings because you've downloaded questionnaire data from an online survey tool, you're going to have huge long variable names which are a bunch of letters squished up together from a sentence, and your label will be your survey question. So do take a bit of time, think about your variable names, maybe put them into Excel before you import your data, and just save yourself a bit of time because you don't want huge long variable names. That's not very useful. Okay, now that we've got our data imported and we have some data with missing data, let's have a look and see how we can code or deal with missing data in SPSS. Now in SPSS, any blank cells are automatically considered missing. That means they won't be included in the analysis. This also means that you do not have to code missing data. It's just an option. However, if you do have a large data set, I highly recommend that you do. It's really good practice to code missing data with a large data set. If you've got something small, it's not essential because your data is a bit easier to keep track of. But if you've got something large, it's a really good idea. So, why code missing values if you don't have to? Well, I don't know if you're like me, but sometimes data accidentally gets deleted. You hit a wrong key on your keyboard and something goes missing. Now, if your missing values are coded, then if you come across a blank space in your data set, you know that it shouldn't be there, that something happened, and you can have a look back at your original data to see what the value should be. Also, if there's more than one reason that the data is missing and you want to be able to distinguish between them. So for example, on a questionnaire, maybe someone chose not to answer a question and they left it blank, that's missing. Or if you have skip logic and they weren't able to answer the question because you didn't give them the option, that would be a different reason that it's missing. So you might want to distinguish and code between those, one meaning they didn't answer, and the other one being that they couldn't answer. Okay, so let's just have another look at our data file quickly before we get on. And we can see there's 3 missing values for the variable travel time min. Now, we want to replace these missing values with a code, and we want to choose a code that's not going to occur for that variable. So, as I mentioned before, sometimes I like to use 99,999, but in this case, because it's possible to have 99 minutes travel time, I don't want to use that as a missing value code. I'm going to use -1 because it's not possible to have negative travel time. So -1 isn't possible, that's why I'm using it. So just choose any numerical value that's not possible for that variable. Okay, so what we're going to do is we're going to replace those missing values with a code. Now, if I had such a small data set as I have now, I could do it by hand and it would be a lot easier. But if you've got a large data set, let SPSS do the work for you, and that way you don't make any mistakes. So from the transform menu, we're going to choose recode into same variables. I don't want to create a new variable. I want to just replace the missing values I have in this one. So recode into same. From this dialog box here, I'm going to find my variable on the left-hand side, which in this case is travel time min, and I'm going to either drag it or use this arrow here to move it into the right-hand side like I've already done. So move travel time min into the numeric variables box. Once you do that, click on the old and new values button, and this is where we're going to recode the data. Now on the left-hand side, you'll see it says old value, and there's this frame around these options, and then there's a frame for new value. We first want to tell SPSS what the current or old value of the data is, and then we'll define what the new value will be. So I'm going to choose system missing or system or user missing. Either of these options would be fine, and that's telling SPSS that we're going to recode anything that is missing in our data set. The next thing we want to do is define what the missing value code is. So I'm going to tick on value and I'm going to type in my code, which is -1. After I type in the code, I'm going to click add, and that will move my missing to -1 over into this box, and that lets me know that it's been successful. Once you've done that, go ahead and click continue from this box here, and then go ahead and click OK from the original dialog box you were at. And if you look at your data, you'll see that all of our missing values have been replaced with a -1. If we go to the variable view, the last step that we need is we have to code those missing values, because at the moment, if we put -1, SPSS will think it's part of the data set and it will include it in the analysis, which is not what we want. We want it to be excluded. So from the variable view, under the missing column, for travel time min, because that's the variable we coded missing values for, I'm going to click into this box, and I'll get this missing values dialog box. I'm going to choose discrete missing values. Discrete just means whole numbers, and our code is a whole number. And I'm going to type in -1 into the box. Once you do that, go ahead and click OK. And that's all you really need to do. Remember, this is only a code. It tells SPSS what values represent, but it does not replace them for you. So just putting a -1 into this missing value code will not put a -1 into all my missing values in SPSS. I have to do that using that transform recode into same variables tool that we just used before. So that's it for the first session. Here's a few books that students have found useful in the past. One is the SPSS Survival Manual by Julie Pallant, and the other one is Discovering Statistics Using SPSS. So that's the end of part 1. Thanks for joining me with this workshop. You can head on over to part 2, or you can take a break, or you can come back another day. I know it's a lot of material to take in, and I'll see you in the next part.